really good idea. We use the beginning of the recording to like do some breathing and center ourselves. Of course.
Could I please have Alex Ashita and Mason Fields to the remote office? Alex and Mason to the remote office. Thank you.
It's like they wait for me to start teaching, and they're like, "Oh, hey, he started class." Woo! Okay. So, if you don't have one of these, which I feel like there's a lot of us, they're moving over here now, so you can secretively come get one. So, if people come in late, tell them to grab a handout from there. Today's lesson is pretty quick and not really that much new content, but we're kind of taking something that we've done and doing it backwards. Now, I gotta tell you guys, just being straight up honest with you, I have to walk out of this building by 45 after, which is in 35 minutes, which is before class is supposed to end, meaning we have a shortened time, because I have to go get a crown put on, and not like your emperors get crowns, a dental crown. Not very much fun. So think about me in the dentist chair, but we gotta get through class first. Okay? Next. Header today is, if you want to make your life easy, distributive property. Distributive property. Yes. No, they use Novocaine on pretty much everybody. They don't use laughing gas very often anymore. If they want to like knock you out, that's fine, but they use Novocaine. They just shoot it straight into your. So the worst thing is the needle into your gum. So they do topical anesthetic, which always tastes like weird.
Also, I need Octavia to the main office, please. Thank you.
So they do that so that you don't feel the needle, but you still do kind of. Then they shoot you with Novocaine. And then they let that sit for like 10 minutes. And then they do everything, which is why I gotta get there on time because they have a scheduled keep. So we gotta get to class. Stevie? Today is 24th, all day. Oh yeah, it's kind of hard to see down here. 24th. So this is on your paper. This is on your handout. You are looking at your white handout. This is on that. Jen's sister made a guess my number game where the expression, and you don't have all the questions that come after this because that's on purpose, is if you add 2 to the number and then triple it, you get 9. Now the dangerous thing that a lot of us are doing wrong with these that I wanted to make sure we address before you get to homework is how that's phrased with the then is like hyperly critical. Then. I would underline the then. Or highlight or circle or something to indicate that's super important. So if I take a number I don't know, add 2 to it, well that's like, like x plus 2. But the then tells us we have to group what we already did and then multiply by 3. So what we're going to end up with here is 3 times x plus 2. I'm going to slide that because my smartboard's messing with me. Equals, she said, 9. Now, there are at least two ways to solve this. I want you right now, while I pop back over to Math 8, to think either on your own or with your partners around you, how do I get to the solution of x? How do we get x by itself? Now, hey, hold up, request. Do not use the entire space that you have open there. Use about half of it, because in case you goof up, we want to be able to cross that out and write the other way. Take like 2 minutes while I pop over here. You can talk to each other if you want. It should be a whole number. It should be a whole number. Yeah. It's not very high quality. Like you're trying to record Emperor's Kids. I mean, probably, yeah. Your phone would probably be better. Let me go get that roll and keep that on. Like, the thing is, I might need to leave you with my laptop and use the software. I do it in my car. What we use. They have them grabbing like now.
Hey guys, just a reminder, I know you're not in full studies class, but what do you have for me tomorrow? Tomorrow? Oh, yeah, we do tomorrow. Don't forget. post it on my page, guys. Yeah. Yeah. You should be. My little brother broke my
All right, there are two, at least, two good ways to solve this. The first one that we'll probably think of is the way there's a poster up here for, right? Bella, what are you thinking? So I'm going to show both ways to do this solution. So Bella, hey guys, if you're talking, you're hurting, not helping. So Bella said 3 times something, right? She said in her head, I'm going to say 3 times something is 9. And especially I told you guys, well, it's a whole number. So then you realize that something must be 3. So she found out, well, x plus 2, this something has to be 3. What Bella actually did, she got rid of this 3 by dividing. If you divide by 3 on both sides, you're getting rid of that 3 times. Right? This is correct. It's a good solution. And then we can find out, Bella, what's x? X must be 1. Now, alternatively, Toby, you going to give me a different way to do this?
Yes.
How do we do it alternatively?
What I did is I took 9 and I divided it by 3.
Well, you're doing the same thing Bella did.
No, I'm not.
Yeah, but that's what she did.
The other way. Because you had to make it like that.
Did anyone not divide by 3 first? Anyone multiply by 3 first?
I think it's
Morgan? You're still taking the same route. Yeah, you're thinking through. This is 3. You're not wrong, but you're taking the same route. I'm trying to go a different route. The other route, we'll go one more, Morgan. You're taking the same route. You're right. You're right. You're right. I'm not saying you're wrong. Hey, give me your attention up here real fast. The other way, especially if the numbers are not nice, is this tells you multiply by both of these. So if you didn't write this method, please do it. That gets 3 times x. And then 3 times 2 is 6, which if you want to write it out, like I'm going to, so we get 3x and 6 is 9. Guys, this is the way we have to take when the math doesn't work out nicely. Let's say this was a 2.5, right? Well, I don't know what times 2.5 equals 9. I know 2 times 4.5 equals 9, but 2.5 would be weird. Or if this was like 7, I don't know what times 7 equals 9. That would be weird. So what all of you guys are trying to describe to me, it works only if the numbers are nice. This always works. So this is our distributive property, right? Like we've talked about before, if it multiplies by a parenthesis, we have to break it up. So now I get 3 times something plus 6 is 9. But again, you're all thinking, well, okay, what plus 6 equals 9? I agree. But how we write that I need you to write, is we get rid of the 6, right? We're saying, well, what plus 6 will get rid of the 6? Please write this on both sides, Naomi.
Wait, couldn't you just figure out like 3 times x equals something, so you plug in the 1, so it's like 3 times 1 equals 3 plus the 6?
Yeah. You're still thinking through if the numbers are working out nicely, which I agree, it works here, but it doesn't always work because the numbers aren't always nice. Guys, the reason we're looking at this with nice numbers is to show you there are multiple options when the numbers are nice. When they're not, there's less options that work well. You could still take the same options, they just don't work out nicely. So here, essentially, we're stuck with 3 times something is 3. Well, okay, if we divide by the 3 to get x by itself, x is just 1, which that's what we're going to find out either way that we took. We found x is 1 over there, we found x is 1 over here. So now, on the next problem they give you, I want you to try and solve it both ways.
Okay.
Try one where we distribute, and the other where we kind of think it through because the numbers work out nicely. So look at 2? 61. This is our equation now. 4 times x plus 3 equals 8. Solve it 2 different ways. One where you divide first, one where you multiply first. Okay, I will be right back. Need more coffee. We would be in 2 places at once.
Hey guys, is everybody doing exactly what they're supposed to do? Exactly. Nothing extra, nothing on the side. I heard snippets of 3 conversations that didn't have anything to do with math. That's why none did that. What?
Are we in advanced science? Down here, but I can't like fall around to show my steps. So I did like x times plus by 1 unit instead of the same time as my mind just went from x to
Get rid of a multiplication. Has everybody done both those methods?
I did.
Some people did. I don't know about everybody. We're talking about our social love.
I should try to pick somebody who looks off task.
Well, I just redirected them a couple times.
Who do you have a good volunteer for me, Mrs. Goldring? You have somebody you think should volunteer? Who?
Here we go.
Did she say Nick or oh, you said Rico, didn't you?
Oh yeah.
All right, and then Rico, you'll get to pick the next person. So Rico, give me one way. Give me one way I can start this.
It doesn't matter which side. Which way?
No.
Oh, okay. Then what's the first thing? You get the 4, and you multiply them. Bing, bing. Yeah.
So the arrows, right?
Yeah.
We distribute. So we do bing and then bing. So 4 times x is 4x. 4 times 3 is 12. Guys, if you don't have this technique written down, please do it right now. I don't care if you have a right answer, if you have a right process. If you don't have both, we want to make sure we have both. Be ready on a quiz for me to say, show both ways to solve this. Hint, hint, nudge, nudge. It'll happen this week.
Oh, yeah. Wait, no,
So at some point this week, you will be asked to show me that you can do both of these techniques. If I didn't go that way, let's stay over here, I guess. Let's stay on this way. So Nick, if I went this way, what's my next step?
Then 4x plus 12 makes 8. But then, like, it doesn't show a negative. So we make, like, subtraction.
Yeah, so we have to kind of force some things.
Yeah.
Hey guys, there is too much side conversation because I bet if I gave you that mini mastery right now, we wouldn't all master it. Which means there's too much side conversation right now. This tells us 4x would equal a negative 4. This can't happen, quote unquote, but we know we can. We just can't physically, right? Like the other one, it was all positives, all made sense. Now, like Nick said, x is going to have to be some kind of negative something. So when we divide on both sides to get rid of the coefficient, remember the number in front of the x is the coefficient. Hey Kayla, we don't really need colors out right now. I just need you writing with me. I know, but you're not with me. You don't have a pencil picked up. That's why I'm picking on you. Is it looks like you're missing writing some things down. X would equal negative 1. Now the other route to take, Nick, who should I pick on next? Ray, if we don't divide first, what could I do first? Or I said that backwards. Sorry. If I don't multiply first, we could divide first. So get rid of the thing where we would multiply by. I should write that in red. We can divide by 4, divide by 4. Now, the only reason we choose this as a good option here, does 8 divide by 4 nicely? Yeah. Guys, if this was like 8 divided by 3 or 8 divided by 7 or something weird, you don't need to take this option, but it is an option. So if Ray takes that option, my left side is now just x plus 3, and my right side is 2. What do we do now to get the x by itself, Naomi? Yeah, a -3 or a -3. I like you thinking -3 because -3 doesn't really make sense, quote unquote. What's 2 minus 3? -1, just like what we got over there. Question. Now to make sure this made sense, I show it to you. I know. I show it to you right here on your paper. Hey, so because I knew some of you wouldn't write this out, because I know you, and even though I stare at you and I say you should be writing this, you don't. This shows he divided first, right? So right in here on both sides, they divided by 4, right? And that's how we got to x plus 3 equals 2. Then, exactly like what Naomi said, think about it like -3. We brought in -3 on both sides to cancel out the +3, and we get -1. Questions? Is that no stretching? This is the same thing. It's on your paper, actually. It's the next thing printed on your paper. It shows you the division process. I know. But I want you writing to push your brains. Right. So, pick one of these, or multiple, depending on how much time you have. I'm going to come back and just give you answers, and then I'll take questions on anything you goofed up. If you're like, wait, that's not what I got, that's an issue. So, really, let's all start with A or B. Pick. Yeah, sure, let's all do A then. If we want to do A, everybody do A right now. I'll write it out down here again in case you can't see. 4 times x plus 1. You can pick which method you want. Yes, on your graph paper. We're out of space on our other paper. I will be right back. Now, here's the trick. We can't start by dividing here because it's not nice. Guys, as soon as you look at this problem, you should kind of throw up in your mouth a little bit. This is gross.
Disgusting.
But we can clean it up. Hey guys, I guarantee a lot of us got this wrong. So work with me. If I go to clean this up, I cannot, and those of you talking not listening are going to be the ones who made these mistakes. I cannot put this one and that one together right now. That one's trapped inside parentheses. I also cannot put this negative x with this positive x because it's trapped inside parentheses. What I can do is distribute. I can do what the 4 times is telling me to do. I can do this. Right? And that's the best option to start with, because if I try to divide by 4, everything gets divided by, and 10 divided by 4 is not very nice. It's okay, but don't do it. We get 4x plus 4 plus 1 plus negative x. I didn't do anything over here. Now we can clean things up. Find your like terms. 4x and a negative x. 3x. 4 and 1. 5.